Hello to my geometry class. So in today's episode, I'm going to be doing number 42 on page 42, and we're going to be doing number 32 on page 52, and number 49 and 52 from last night's honors homework on page 43. Hope you enjoy it. Hope it's useful. Let me know in the comments. Let's get it on today's episode. So as we know, the very first thing I always ask you to do is what? You should be saying it out loud right now. Draw a diagram. That's right. So here we go. Number 42 says, the measure of angle EBC equals 3r plus 10. Measure of ABE equals 2r minus 20. Find measure EBF. So now that I have these things, I want to start labeling. So first I want to look at my picture here, right? So I drew these two things in there because they're on the book. Thank you if you said God bless you. So one thing we want to notice in the beginning sentence of this problem set from number 37 to 42 is BA and BC are opposite rays, and BH bisects EBC. So right here, so we can say that this also equals that. So it looks like that could help us out, but we're not really sure. So let's look. EBC equals 3r plus 10. Go ahead and label that right now if you haven't already. So we see EBC equals 3r plus 10. So what I'm going to do is I'm going to lengthen this out a little bit so I can kind of draw it over the rest of it. I'm going to say that that right there is 3r plus 10. So let's have sort of a visual on it. Next, ABE is equal to 2r minus 20. ABE, so ABE right here is equal to 2r minus 20. All right, so that's right there. And then it's asking me to find EBF. EBF. Am I doing this right? EBC is 3r plus 10. It's giving me that. All right, so it's asking me for this one. So I know that this is equal to this. So I can easily just say this right here is 2r minus 20. All right, from there, interesting. Well, I want to find out what r is. The question is, do I have enough information to accomplish other things? Oh dear. So we can see that these two are equal. So we could say that EBC, I'm going to say measure of angle EBC is equal to the things that make it up. So EBF, measure of angle EBF, plus FBH, plus the measure of HBC. All right. So if I were to think ahead about this, I feel like I can't really use this yet because I only have that, so I can't really say that this has any relationship with that. One thing I do know is that these two are equal, so, and I know that that's equal. I know the whole thing's equal to 180 degrees. I'll be honest, I'm a little confused right now, so I'm going to come back to my problem and double check I'm doing things right. And the figure BA and BC are opposite rays. All right, that's fine. And it says BH bisects EBC. So it's saying that Oh, all right. HB bisects EBC. All right, so it's not saying that this and this are equal. It's actually saying, I'm curious, comment if you caught that mistake right there. Right, so it's saying that actually this and this are equal. But my picture also shows that EBF is equal to ABE. All right, so now I have a little bit more information. So I can say that this right here is 2r minus 20, and that this and this are equal. Well, this is all very interesting. This still remains true. EBC equals 3r plus 10. Comment if you're figuring things out before I am right now. ABE equals 2r minus 20. And P.S. sometimes the reason I get through problems so much quicker and I discover things is I'll ask you questions, and oftentimes I've done them out beforehand. I haven't done this one out beforehand. That's why I'm struggling a little bit. All right, so I have this equation. I'm gonna also just go ahead and say, so I wanna find EBF. So I'm gonna underline everywhere I see EBF. And I'm going to star the things that I know. So I know the value of that, FBH, FBH. I don't necessarily know the value of FBH. But actually, that doesn't really matter because I can also write, I'm just going to shorten it, I'll just keep writing. So I can also say that the measure of EBC is equal to EBH plus HBC. Because I know these bisect, I can also say that these two are equal. And I don't necessarily know the value of either of them, but I do know that ABE. So here's what I'm thinking, is that there should be 180 degrees across this whole thing. So maybe I'll just run with that. I feel like that would be reasonable. Otherwise, they couldn't really ask that of me. Now, it doesn't say, there's no degrees in the picture or anything. There's no degrees in what things are equal to. But if I know that those are equal, EBH, I know that EBH, it doesn't give me those. You know what? I think it must have to do with the 180 degrees because I know that this whole thing is equal to 180 degrees. So I could say that this plus, let's see, this plus this equals 180. And I can say that, and then I can figure out F, B, and H, and then subtract that. So I'm just gonna go ahead and I'm gonna assume that they're saying that I can use the fact that it's all 180 degrees, that it's correct. So I'm gonna say 180 degrees is equal to 3r plus 10 plus 2r minus 20. All right, now I can solve for r at least in terms of degrees. Let's see, we get 5r. This is going to turn into negative 10 equals 180 degrees. So we can say that we can add 10 to both sides. I'm going to get 190 equals 190 over 5 equals r. So let's see, 5, let's see, 19 times 10 gives me 190. So 19 times 2 is going to be 38. So R equals 38. All right, so I have that much information. So do we have enough information that so we're solving for, again, EBF up here. So if EBF equals 2R minus 20 and R equals 38, so that should be 2 times 38 is going to be 60 plus 16 is going to be 76 minus 20 equals 56. And that's what the book says. So what I was missing here is that I wasn't sure at first if I could use the 180, but we realized that this plus this, the two things that they gave me, added up to 180. And so once I knew that that would be useful because I could solve for R with that. So once I knew I could solve for R with that, then I could say to myself, well, if I plug in R into here, then I'll be good. So I was wondering if there was a chance I was going to have to figure out some relationships in here, but it looks like I'm all set. So that right there is number 42 on page 42. Final answer 56. 56 equals the measure of angle EBF, and R equals 38. Moving on. Fast forward to page 43, number 49. So 49 is saying, draw an obtuse angle. Draw in, let's see, 49, zoom out. Draw an obtuse angle named ABC. Construct an angle bisector BD of ABC. So an obtuse angle named ABC. So I'm going to put it up here. I got some space. So call that ABC. And an angle bisector of BD. BD. That's a bisector, those are equal. Explain the steps in your construction and justify each step. Classify the two angles formed by the angle bisector. So I wanted to make an obtuse angle, so I said to myself, I know that I want this right here to be greater than 90 degrees. And I saw that if I were to draw my line up here, that would be about 90 degrees. If I drew it out here, it would be greater than 90 degrees. Next, I said to myself, well, DB is going to have to be in the middle. So I could say that this is not drawn to scale. It's probably pretty close, but probably not perfect. And so I drew it the best I could. If I were to do this again and make sure it were to scale, let's try this. And so that's straight down. This is going to be at a 45-degree angle. So I know that right there, that would be 90. So 90 plus, and I know this is going to be a 45-degree angle because it has a slope of straight -1 plus 45. So that's 135. Ooh, 135 divided by 2, that's going to be gross. But let's see. I'm trying to think of what would be an easy way to do things. Well, let's think. I'm trying to think of using graph paper. What other things do I know how to draw? So if I had to draw this to scale, how could I do a 30, 60, 90? No. Let me think. See, if I do that, that's 45. If I do this, this is 45. I know this is 45. So the hard part is getting, so I'm just going to draw some dotted lines because that's not my actual diagram. but I want to find a way to draw a point directly in the middle. So the question is, what would be a perpendicular line I could draw that I could find like the midpoint of? Kind of struggling here. Let's see. 45 degrees. In the comments, feel free to say, well, if I had to draw something to scale with no protractor, but I had graph paper here, how could I do this? What would be the simplest way to do it? So 180 is not an obtuse angle, it's just a straight line. 135, I can calculate that. How could I get this so it's exactly 22.5 right here? Well, I guess if I were to draw a dotted line here, if from here to here ends up halfway between, I think that should work. The question is, say I extend it out 2 more, right, and draw that dotted line. If I were to draw that same line, so this is 1, 2, 3, 4, 5, so it should end up about there, and this is 1, 2, 3, 4, 5, 6, 7, so that should end up at 2, 3.5. All right, and then let's do one more. So this is 1, 2, 3, 4, 5, 6, 7. This would be 8, so I want it 1, 2, 3, 4 right there. So let's see. I'm going to use a piece of paper as a straight edge here. What do I got? I'm just going to use this. All right, so I got this right here, and I want to draw it right along there. That right there looks to me like it would be straight down the middle. So I think I can say that this is 22.5, and I think this is 22.5. So I would say that's about the closest I can do using graph paper without a protractor to figure out if those two lengths are equal. It's kind of hard to tell. Hey, let me know in the comments tell me if I can prove whether this is actually 22.5 or not. And maybe I guess one way I could figure it out is I could use trigonometry, and I could say, let's see, if I were to draw this one, I know that this right here is 4 units. This is 1, 2, 3, 4, 5, 6, 7, 8 units. So if this is 8 units, so I'm going to use tangent 8 units here. So for my honors class, you did not have to do this. I was anticipating you'd kind of eyeball it and then just label your chart like this one. But if you wanted to go over the top, you'd say the tangent, so opposite is going to be 4. Adjacent is going to be 8. Tangent 4, 8 gives me what in degrees? Did I do that right? No, sorry, it's gonna be tangent 22.5. I wanna see if that comes out to, I wanna know if that comes out to 1/2, so let's check. Let's see if I did it right. All right, so I go to tangent, and I'm going to go to 22.5. I'm going to have to check to see in a minute if that's degrees. Let's give me 1/2. No, it gives me 0.41, so let's see. I'm trying to remember, where does it tell me if I'm using the correct one? Maybe mode? Yep, it's in degrees. Or am I doing that? It's been a while since I've done some trigonometry. Let's check. Or did I do it backwards? Is that going to give me 22.5? Nope, so it looks like I didn't quite make it there. But if we had to make something that bisects, it would be easiest if we had a protractor. We could measure to see, so it looks like I'm not accurate. These are not actually 22.5. I give it my best shot here to try to find it even in the middle, but we want to find out a way to make it exactly halfway in between. I'd love to know how could I do this with graph paper and make some angles in here to figure out how to make that exactly halfway in between. All right, so that is 49. This is number 49. All right, and skip ahead to 53, writing in math. So the question states, Rashid says that he can estimate the measure of an acute angle using a piece of paper to within 6 degrees of accuracy. Explain how this would be possible, then use this method to estimate the measure of the angle shown. So it's right here. So let's think. How could we use a piece of paper to measure within 6 degrees of accuracy? Well, let's think about this. If I know that a right angle, that is going to be 90 degrees. And let's see, how many times does, so I'm thinking if it's within 6 of any correct answer, could I take 90 and divide it by 6? What do I get? How many different sections would I have to sort of put it in? So let's see, take 2 out of both, 45 over 3, 15. So I guess if you were able to draw something that went over, let's see, 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10. You know, if you were able to get that 15 wide, and then you were able to put it on the paper, I think that could be a good way to do it. I'm rereading the question. Rashid says that he can estimate the measure of an acute angle using a piece of paper to within 6 degrees of accuracy. Explain how this would be possible, then use this method to estimate the measure of the angle shown. I'm guessing, well, if you were to take this and let's just assume that that this is our angle and we're trying to figure out what that is. If you were to cut this, if you were to take this piece of paper, fold it in half, you could figure out 45 degrees. So let's do that. You know what? So I got this red piece of paper right here. Hold on. Hold on. So I know it's probably going to be, I'll just cut it and make it not upside down. I can't see through that. Let's see. Can I find a piece of paper to see through? Good enough? All right. So I'm going to try to see if I can get one of those lines matched up. Looks like that's our line right there. So I'm guessing he's going to be able to fold it into 6 pieces. So let's see if I can keep extending this out. How long can I extend this for? So if I were to take this all right, so I know that that's what I'm measuring, but if I have that right there, then I can figure out what 50, I should be able to tell. I'm going to do it on the outside. I'm going to match up my lines so that I just matched up my lines, so that's at 45 degrees. Let's see, where do I go from there? I used a piece of paper. Rashid says he can estimate the measure of an acute angle using a piece of paper to within 6 degrees of accuracy. Explain how this would be possible, then use this method to estimate the measure of the angle shown. So we're talking right here about this measure. So I know it's going to be greater than 45 at least. So I know it's going to be greater, say angle X is greater than 45. I know that much. Trying to think. So I mean, I even have the solutions here. I'm trying to think before I just cheat and check it. And I want to. Sometimes I think it's useful having someone talk out loud about what they would do. Within 6 degrees. Well, I guess I could fold that in half, and that would give me 20. That would be in between, let's see, 90 minus 22.5 would give me 70. That would give me 67.5. So that's what I'm going to try to do. I'm going to fold this piece of paper, match up that line and the crease that I already made, and with that, depending on what side it's on, I can tell whether it's 67.5 or not, or yeah, 67.5. So I'm gonna, hopefully I made my mark dark enough. All right. So now I know that's gonna be my 67.5 mark. So I know that my X is, let's see, X is less than 67.5, and I know that it's greater than 45. So now from there, let's try to match up those two. So the bigger the piece of paper, the easier this is gonna get. But if I take those two folds and I try to match the lines together, hope you can see this pretty well. So I'm gonna try to push that down so that my folds are matching. No, that's not quite it. There we go. All right, so now I have, I'm gonna draw a little dotted line. So this was that was my 67-degree fold. This is my 45-degree fold. 67 and 45, this new crease right here is going to be halfway between those, and I can tell that it is less than that. So what I can say now is not only that it's less than 67.5, but halfway between 45 and 67.5, that's 12.5. Half of that, so I can kind of cross off this section right here. So 12.5 divided by 2 is going to be 6.25. So I can subtract 6.25 from that, and I should get 61.25. So I know it's going to be greater than that, and it is going to be, sorry, it's going to be less than 61.25 and greater than 45. See, so he's saying he can get it within 6 degrees. Well, I'm at about 15 degrees, so I guess I could do it one more time. That's pretty tough, though. I mean, I would say that right there is pretty close to in the middle between this crease and this crease. So, and I would say it's a little bit more on this side. So, if I were to cut that in half, I'm just gonna go ahead and guess that the halfway is like right next to it. So I'm gonna say that it's a little bit I'm gonna say that if I were to cut this in two again, between 45 and 61.5, wait, did I do that right? Yeah, so the difference between those is going to be 16.25. So 16.25, and I'm going to say that it is not in this region. So of that 16.25, I'm going to divide that by 2, and that's going to give me 8.125. I think I messed up that part. Maybe I could have just taken off 12.5. Take off 22.5, and then I can take off the difference between that. All right, so I'm going to take off 8.125. No, that's too much. It should be somewhere in there. I messed up my math somewhere, but I know that I would say this is probably how they did it. So now I'm going to read the book answer. Where are you? Answer 53. See Chapter 1, Answer Appendix. All right. Sample answer. To measure an acute angle, you can fold the corner of the paper so the edges meet. This would bisect the angle, allowing you to determine whether the angle was between 0 and 45 or 45 and 90. I did that. If the paper is folded 2 more times in the same manner, cut off this corner of the paper, and fold lines would form the increments of a homemade protractor that start at 0 degrees on one side and progress to 90 divided by 8, or 11.25 increments, ending at the adjacent side, which would indicate 90 degrees. You can estimate halfway between each fold line, which would give you an accuracy of 11.25 degrees divided by 2, or about 6. The actual measure of the angle shown is 52 degrees. An estimate between 46 and 58 would be acceptable. All right, so I was going to subtract 8 there. Let's see, if I were to subtract 8 from the 61, I think I would have got right around, let's see, 1.25, and then 61 minus 8 would be 63.125, and I'd said it's a little bit less than that, so it would have been between 45 and 53.125. So yeah, I think I would have been pretty close. Well, there you have it. And lastly, is that all I was going to do? Nope, I said I was going to do one more. All right, so now we're looking at page 52, number 32. So first it says use the figure at the right. So I'm going to draw my figure. If you have the book in front of you, take that time right now to do this. All right, so I got P, I got J. All right, now, number 32, it says JNP. JNP right here is going to be 2x plus 3. It says KNL equals 3x minus 17. KNL equals 3x minus 17. And KNJ, where's J? Oh, sorry, KNJ is equal to 3x plus 34. And find the measure of each angle. So I'm just going to take this all the way. Let's find 1, 2, 3, 4, 5 different angles. So first off, we know that this plus this plus this is going to equal 180 degrees. So 180 degrees is equal to PNJ, or 2x plus 3, JNK, or 3x plus 34, plus KNL, 3x minus 17. All right, let's figure out what x is. I have enough information to solve it. 2x plus 3x plus 3x is 6, 7, 8x, plus 3 plus 34 minus 17. 34 minus 17 is 17, so 17 plus 3 is 20. Subtract 20 from both sides. 180 equals 8. Whoop, 160 equals 8x, x equals 20. All right, I have that. Now, put 20 into x. 2 times 20 is 40. 40 plus 3 is 43 degrees. 3x, so 3 times 20 is 60. 60 plus 34 is 94. 3 times x, or 60 minus 17. 60 minus 10 is 50. Minus 7 is 43. Interesting, so these are equal. And over here, I know that, let's see, this is going to be a vertical angle. JNP is vertical angle to LNM, so this is also 43. And we could say that this right here is vertical to this. So 94 plus 43 is going to give us, let's see, let's take away 7. I'm doing this in my head. Take away 7 from here. Take away 3 is 40. Take away another 4 is 36. So that, whoop, I just needed 6, sorry. Take away 6 from here to add to here. Take away 3 is 40. Take away another 3 is 37. So I got 100 plus 37 is 137. So we have 43, 94, 43, 43, 137. Let's double check. Let's just make sure that all adds up to 360. So I got 1, 2, 3 times 43. 9, 12 plus 94 plus 137. So we get 9 plus 4 is 13. Plus another 7 is 20. 2 plus 2 is 4, plus 9 is 13, plus 3 is 16. Looking good. 1, 2, 360 degrees. We're good. And that is our answer to number 32 on page 52. So, thank you for watching. Thank you for watching. I hope this has been useful. I'm going to try to get this posted ASAP. Put in the comments any questions, anything else you'd like me to review. This weekend, I'm going to be giving a take-home test to both my geometry courses, CP and honors. So feel free to use this as a study guide. Thanks for watching. Stay weird.